In this hands-on lecture, I will discuss about stop words and stemming and look over them through the code base y-TextMiner. If you recall correctly, there are several utility Java classes for this exercise, which I mentioned last lab session. One of them is token.java. So why don't you open up token.java by clicking on token.java. So by double clicking on token.java, you see constructors and some functions provided in token.java. Stemming is stemmer-based stemming class. So let's look at Porter class located at the preprocess package. In the lecture note, I covered the Porter stemmers. This Porter class is Java implementation of Porter stemming algorithm. We will not directly use this, but it will be used by core NLP preprocess Java class when we call the preprocess method. So inside core NLP preprocess Java class, there is several preprocess functions. Inside one of preprocess function, there is one line of code which called Porter. Okay, this Porter, if you right-click on strip affixes and select open declaration, then it will take you, let's do this again. If you right-click on strip affixes and select open declaration, then it will take you to Porter stemmers class and the function called strip affixes. And this string affixes will be based on the several rules that defined in this Porter stemmer. It simply implements Porter stemmer algorithm in Java. After cleaning and then goes through 6 steps, the original form of word will be reduced into the stemmed form of the word. So when you call preprocess by passing sentence object to this preprocess function of core NLP preprocess Java, and it calls inside this function, it calls another preprocess which the type is private, and in there it calls Porter stemming algorithm. And then this Porter stemming algorithm is based on original text. So sentence original text is stemmed, and then it will pass to the token object. So token object gets stemming form of original token. So let's go back to token.java. So token.java, when you call preprocess of token class, then it calls core NLP preprocess, and the next line is preprocess function of core NLP preprocess. So now let's create one simple main function. By now, you must be able to create a very simple function of this exercise. Let's call this stem and stop main. So let's create that simple test driver class under main package. Right click on the main package and select new, and then select class. And then you type stem and stop main. My case, I already created this main class, but in your case, you won't see this error. So by simply clicking on finish button, you will have skeleton of stem and stop main.java. Let me close this out. Okay. Very simple structure, same as before. I instantiate scanner. I pass the sample data set, in this case, Twitter data collected by Stream API. Then first 10 lines, I create sentence object as before, and then sentence object's preprocess function is called and executed, and after that we call getStem of the token. For this getStem of token, you will see the stem form of the token. But let's say I want to see the original token, original format of token. Then let's, I don't know what happened. Okay, then token, oops. Token dot, then I'm going to select get token. This should be original form. So then let's save this. The first thing is very similar as previous examples. So you must follow this very easily up to here. And once you get the sentence tokenized and preprocessed, and then you can call each token from sentence. And the sentence has a number of tokenized terms along with the stem form, POS tagging, whether it's a stopword or not. And you will be able to print out all of those available information by doing this. After that, so let's call this is stopword. Okay, is stopword. So for the same set of tokens, we're going to examine whether a token is stopword or not by calling tokens is stopword function. Then if this token, then, this is a stopword, then you will say stopword. Okay? If not, then you simply say not stopword. Okay, so by doing this and save, after that you just simply right click on stem and stop main.java and then select run as and select run Java application. And the same, the logging messages, and after the end of logging message, you will see the tokenized word. So let's say yellow, okay, is not stubborn. It's not stubborn, okay, and let's say this hashtag not stubborn and Coldplay not stubborn and Beyonce is not stubborn and so on and so forth. So you will check whether each tokenized term is stubborn or not. So after this, you're probably going to create bag of words after removing stubbers, after stemming or lemmatization, and create cleansing the text, and then you will do other text mining tasks such as clustering, classifications, and so on and so forth. So let's take the stemming. Okay, this is a stubber. Another one is stemming. So stemming is a very simple. As I explained before, you will get the original token and its stamped form. So let's look at after stemming. "44" is 44, yellow, yellow. Okay, so it's a we intentionally make this word lowercase. The original form, yellow, starts with capital Y. When you, the reason is we want to normalize the words to minimize the variation of terms. So in this case, help is stem form for help. And I must include another white space, but I didn't do that. So that's why you see these two terms concatenate each other. But let's say it's separated. Come is stem form, coming is the original form, which means ing is stemmed into e. So once you're familiar with this stopwords and stemming preprocessing stage, you will be much more comfortable with dealing with unstructured text data.